Hello, good evening everybody. My name is Keith, and tonight we're going to find roots of complex numbers in polar form. Tonight our question is find all the complex square roots of w equals 16 times cosine of 30 degrees plus I sine of 30 degrees, and write the roots in polar form with theta and degrees. So what we want to do is we want to use DeMar's theorem for finding roots, which is z sub k equals the nth root of r times cosine of theta plus 360 degrees times k over n plus I sine times theta plus 360 degrees times k over n. And that's the formula in degrees, and our problem tonight is in degrees, so we'll use that formula. We want to find the square roots of that complex number, and we'll create the expression using that formula. And in our expression, r will be equal to 16, theta will be equal to 30 degrees, and n will be equal to 2. When we build that problem, we will substitute the first value of k, which is 0, into the equation, and we'll get z sub 0 is equal to the square root of 16 times cosine of 30 plus 360 times 0 over 2 plus I sine of 30 plus 360 times 0 over 2. When you simplify that, it simplifies down to 4 times the cosine of 15 degrees plus I sine of 15 degrees. And since that is a complex number in polar form, that is the answer that we're looking for z sub 0. If you calculate the second complex square by substituting the value of k equals 1, you get z sub 1 equals the square root of 16 times cosine of 30 plus 360 times 1 over 2 plus I sine of 30 plus 360 times 1 over 2. When you simplify that down, you get the square root of 16 simplifies down to 4 times the cosine of 30 plus 360 is 90 times, 360 times 1 is 360 plus 30 is 390 divided by 2 equals 195 plus I sine of 360 times 1 plus 30 divided by 2 is 195. So our answers for each of the complex squares are z sub 0 equals 4 times the cosine of 15 degrees plus I sine of 15 degrees, and z sub 1 is 4 times the cosine of 195 degrees plus I sine of 195 degrees. If you have any questions or you need me to elaborate on anything, please let me know, and have a great evening.